Hi, I'm Ezhilarasi, product consultant of Serverless 360, and it gives me immense pleasure to talk to you all today to share my experience after Microsoft Ignite. So the agenda of this 1 hour webinar is going to be, first, I would like to quickly share my experience at Ignite as we represented Serverless 360 at the massive conference Ignite 2019. And what was our learnings out of the conference, meetings that we had with the attendees of the conference, our customers, and the consultants, they walked into our booth. What did we learn out of them? In the perspective of the Azure Serverless Services that are most used or which was found most famous among the attendees at Ignite 2019. And how do we put together these Azure Serverless Services to build a real-time serverless application? Because as long as we get our hands dirty on trying out using these serverless services, we often do not discover the real potential and the real challenges in using them. And later we will find how Serverless 360 can be the best complementary tool to Azure Portal in improving your experience in dealing with Azure Serverless applications. So this is going to be the agenda for the next few minutes as we talk on this webinar. At any point in time, if you have any questions, feel free to post it on the questions section. I would take them up soon after the presentation. And in case of any trouble in listening to me or in following the screens, just raise your hands. I have my colleagues who are also there as panel members who can attend to you to help you out. So our exhibit at Serverless 360 at Ignite conference, it was a huge exposure wherein we had a platform to connect with the actual end users of Azure services. And this gave us a great opportunity to connect with the leaders in the Azure platform who have played significant role in deciding what their Azure orchestration should look like in their organizations. So we had quality discussions through which we tried to understand how exactly the Azure Serverless Services are being utilized, and we had an opportunity to exhibit what Serverless 360 has got to make their Azure experience much better. It was so encouraging when we found that our customers or the attendees at the conference acknowledged that our understanding on the challenges in managing and monitoring the serverless services are right. And it gave us a confidence that we are building a product which addresses the key challenges that any user would encounter as they start managing and monitoring their serverless applications in the Azure portal. And to start off with, so what did we learn out of Ignite 2019 was quite interesting. So here is an refined list of some of the Azure services which we found most of the attendees saying that they have got them on their Azure orchestration. So each of these services have a significant role to play in your Azure serverless architecture. Say like when we pick up a logic app, it would be an ideal service which can define our serverless workflow orchestration with it can orchestrate how exactly your business process should work. What are the sequence of actions that should follow one after the other to execute your business process? So whereas when you need flexibility to write your own code to perform any legacy computation, then the function app would come into picture, which can help you build your own code, run it on the platform as a service, and make sure that your logic is achieved. And when you have a stream of events to be ingested and you want an analytics to be built out of it, then Event Hub is there for our rescue. And any transaction wherein you need a messaging structure, then Azure Service Bus is there to help us out. And event routing can be achieved with the help of Event Grid. So these are at a very high level, but I think it is necessary for us to get a little more deeper, trying to understand how each of these services are significant in building our business orchestrations. So let me go into each one of them one by one. And whereas in common, they all have a common power of being serverless services. Say you just pay for what you use, and they can scale seamlessly to meet the requirement of our business, and they are all very simple to use, wherein I just focus only on the business that I want to achieve. So with that introduction, let us look at each one of them in detail. An Azure Logic App is a workflow triggered by an event. When I say a workflow, it is going to have a sequence of steps that defines how my business workflow is going to be. So these Azure Logic Apps have a no-code designer that would help me in rapid application development. It will give us an easy way without writing code to do integration with the cloud and to automate it. I need not go through hours or days together to get it set up. With a simple user interface, it should help you to get started in a matter of minutes. And this simplification should help broaden the user base and make more people willing to use Azure. So let me quickly show you how the an interface of creating a logic app would look like. And with that, you can very easily make out how simple it is to start off with a logic app. So logic app has got a huge list of connectors readily available, which can fit in directly into our business requirement. And this is one of the main reasons why they are so popular among Azure users. And Logic Apps will allow you to consume custom and reusable APIs more easily. Like you can even build Logic Apps with custom connectors. It has got a lot of predefined templates, as you can see here, which can be readily made use of. Along with that, it can also support on-premise APIs and popular SaaS APIs, which can help you address complex and advanced integration scenarios. And you still have an option to use more advanced APIs like bespoke services. You can even build your own custom APIs. With this, you can build your own custom APIs and integrate them with the Logic Apps. If you have your own interfaces and your own internal systems that you want to use, you can do that using API apps as the API connectors, which will give you a bridge into any legacy apps you have, so that they need not be moved into cloud all of a sudden. And with Azure, everything with your Logic app is hosted and managed on your behalf for you. And you would only have to worry about managing the code that you want to write for yourself. So this is one of the key reasons why Logic App is really powerful. And out of this scaling, like being on Azure, you will be able to grow to meet the demand of your customers and clients. And you'll be able to deliver the apps at a massive scale from tens to millions of concurrent users at the same time. So, and one of my favorite capabilities of Logic Apps is its inbuilt exception handling. So it has got retry policies which can be configured at ease and ensure that your business happens without any exceptions. Next comes the Azure Functions. So whereas Azure Functions different from Logic Apps is, this is code being triggered by an event. So similar to Logic App, it can be triggered by an event. When I say an event, it could be a message coming in to your service bus queue, or a blob getting added to a storage account, or it could even be a trigger by a timer trigger. So this Azure function will help us achieve a code being triggered by an event. You can write a code in an easy to use web interface, or you can use your favorite development tool to build and debug. And the choice is up to the developer. Even with the programming languages, we do have a lot of options to choose from. An Azure function has an intuitive browser-based user interface to respond to events generated by event hubs, HTTP triggers and timer triggers, Azure Blob Storage, and Azure Storage Queues, and so on. Say here is an interface of an Azure function creation browser interface, wherein you can choose to select from one of the available triggers, and after which you have an option to choose your programming language too, wherein I have a wide variety of support like C#, F#, Node.js, Python, PHP, and Java, and whatnot. And being an event-driven application platform, it has got capabilities to implement code triggered by events occurring in any third-party or on-premise systems too. Because as you have seen, there is an HTTP trigger also available, which means this can be triggered even from my third-party service or an on-premise system. And Microsoft has made functions runtime portable. So it is easier to build and deploy serverless applications on any public cloud or on your own internal network. So this way you can ensure your serverless code will run anywhere. As the runtime is portable, you can run the functions anywhere, other clouds in the data center or in Azure too. And this delivery model ensures compute on demand. The resources are available to the users as per their demand. The user doesn't have to worry about the provisioning or managing them anywhere, but rather we can focus on the business logic, the core business logic that we would like to achieve. And it is easy to implement custom features with its platform because runtime templates, UI, and the underlying web jobs SDK are all open source. So it is open for us to customize and implement the custom features as we wish. Next comes the Azure Service Bus. Say in any integration solution, say let us pick up an e-commerce scenario, which is very common to us, transaction or message handling becomes an integral part of it. So I need a fully managed enterprise integration message broker, which can carefully handle my business transactions. So this service bus can decouple applications and services. That is, I no longer need both my client and server to be online at the same point in time. So I can securely transfer data between my application and my services with the help of Service Bus. And this offers a reliable, secure platform for asynchronous transfer of data and state. So I want to emphasize here on asynchronous because at this point in the world, like every one of us wants to be served by the application as if we are the single user. So to achieve this, asynchronous data transfer becomes integral, which can be very efficiently handled using messages. And a message in service bus can be in a binary format that can contain an JSON, XML, or just a plain text. So all these message formats are allowed or acceptable by service bus. And what makes Azure Service Bus more powerful is its advanced features. So I would like to emphasize here on few of the advanced features which will help me really fit them into my business scenario. Say a dead letter queue. So every service bus queue has got a dead letter queue which takes care of holding the undelivered messages. So this would be of great help to me when I deal with a real-time business scenario. Imagine my service bus queue is expected to receive any new orders my customer pushes in. So in case if my client application, which is expected to pick up these messages and process, has not picked up this message, the message should be notified to me that this unpicked or undelivered. So in this case, the dead letter queue will come into rescue, wherein the message can be set with a specific time to live, and you can turn on enable dead lettering on expiry so that the message is getting pushed into my dead letter queue. So I get to know that when an customer order is unprocessed beyond a specific time. Duplicate detection. So when you enable this property on the service bus queue or a topic, it helps me ensure that every message that gets into the queue has got a unique message ID. So this is a very common requirement in my business, wherein I need to ensure that there is no duplicate orders processed within the duplicate detection time frame window. So I can specify a duplicate detection time frame window and enable duplicate detection property on my topic or queue, ensuring that none of the duplicate orders are processed. Scheduled delivery. With this property, you can ensure the message is available for my client application only on a scheduled time. Auto forwarding can help us forward all the messages that comes into a service bus queue or topic into another service bus queue or topic. So this a scenario I can think of where I can use this feature is when I have to take my service bus queue into maintenance, I can set an auto forwarding, ensuring that the messages coming into this queue is automatically forwarded into another service bus entity, which is being picked up by a client application that listens to that. And messaging sessions can help us ensure first in, first out. A guaranteed first in, first out and service bus can be ensured with the help of service bus messages, sessions. And when we talk about service bus, it includes queues and topics. So when you need an one-to-one delivery, and then service bus queue can be the best solution. But when you want the same message to be passed on to multiple of your subscribers, then we have the service bus topic with multiple subscriptions which can be used to fulfill this business requirement. And when we have multiple subscriptions, the topic subscriptions are equipped with filters which can help us auto filter the messages using rules. An Azure Event Hub. So, an Azure Event Grid is an event-driven computing solution. Say here it is quite simple. You can point and click to aim the events from an Azure resource to any event handler or endpoint. Say for example, Event Grid supports a number of Azure serverless connections which will help you bind your event sources and event handlers. So what Event Grid does isn't simple routing, but in push model. Say, how is it different from a pull model? Say when the handlers are expected to continuously poll on the event sources to look for any event to happen, then it might involve additional cost because there is a continuous polling happening, irrespective of whether an event is ready to be processed or not. But this event grid can save cost by adopting to push model. So it ensures that you get the event handler is informed when an event is ready for processing. So the supported event sources can be any of these lists, and the supported event handlers could be any of this list. And in fact, this solves most of the real-time business requirements with an added reliability, like a 24-hour retry with exponential backoff to make sure events are delivered. So this way, an event routing using event grid becomes most reliable. And you pay only for the amount you use. It ensures high throughput. You can build high volume workloads on event grid with the support for millions of events per second. And you can get up and running quickly with the resource defined built-in events. You have got advanced filtering options. So filter on event type and event publish path to make sure that event handlers only receive relevant events. So when I have multiple event subscribers or event receivers, I have to ensure that only the relevant events get into each of my subscribers. So this can be achieved with the help of advanced filtering. And it is also possible to fan out. You can subscribe several endpoints to the same event to send copies of the event to as many places as needed. And custom events are also possible. You can use event grid, route, filter, and reliably deliver custom events in your application. So these event grids can help us build loosely coupled applications. Say like my recipient application can continue with its job as long until it receives an intimation through an event grid that the data is ready for me to process. And here comes an event hub. So event hub is an event ingester in your serverless architecture. So, and what is an event ingester? It is a component or service that can sit between an event publisher and an event consumer. So this helps in decoupling my production of event stream from the consumption of these events. So this event hub is capable of like ingesting millions and millions of events at a time without any performance degradation. And it's a fully managed platform as a service with a very little configuration or management overhead. So you can focus on your business solutions that you would like to build. Event hubs can support both real-time and batch processing. Say like it can ingest, buffer, and store and process your stream in real time to get the actionable insights. Or it is also possible to capture the data in near real time. So how does it support real time is using the partitioned consumer model. So Event Hub can be designed to have multiple partitions, and there are multiple applications to can listen to each of these partitions to process the stream concurrently, letting you control the speed of the processing. And with capture enabled, Event Hub can capture the data into storage options like Azure Blob Storage or Azure Data Lake Storage for long-term retention or micro batch processing of this data. So you can achieve this behavior with a simple setting on your Event Hub. You just turn on capture. Can quickly show you how does it look like. Say here is an Event Hub namespace wherein I can create an Event Hub with the settings that can enable capture. So when I enable capture, this Event Hub will be equipped to capture the information into an storage blob or data lake storage. So it will prompt me to choose one of my capture storage to which I can ensure the incoming events are ingested and stored into the storage blob so that any of my application can take its own time to process these data. We can set up a message retention duration, say how long the message should be retained in your storage or in the Event Hub. And you can, when you want to do in real-time processing, you can enable partition. Multiple partitions can be listened by multiple of our client applications to consume the data and get with the analytics part. And it has got a rich ecosystem. Say like event hubs can integrate with Azure services like Azure Stream Analytics or Azure Functions, and thus it enables you to build serverless architectures. And it has also got compatibility with event hubs for Apache Kafka. So you need not do much of setup or configuration to manage your own Kafka clusters. With a broad ecosystem available in various languages, you can easily start processing your streams from event hubs. And it is supported by client languages which provide a low-level integration. So enough of theory, isn't it? So like we have discussed a lot about the top 5 most used Azure Serverless services. So now to better understand them, should we put them into a real world business application, trying to understand where does each of this service fit into to build my business application? So let us pick up an example which is very familiar to all of us. So we would have used the cab booking application day in and day out. So let me pick up an MVP of an cab booking application. So I name it a flywheel cab booking application, which I have segregated into 3 main components for me to easily address its requirements. So one is a vehicle management component, which takes care of real-time tracking of all the cabs that I have associated with my flywheel application. So I want to know where does the cab exist at any point in time. So all of my cabs are installed with the telematic devices, which will keep sending in telematic information about its location, its fuel consumption, or how is it performing, what is its due for insurance and all. So I have got the devices set up on my cabs, which is going to stream me the telematic information. So I need a system which will ingest the stream of information, convert it into my required analytic information to take necessary decisions. And I have an driver onboard management system, which will onboard drivers into my flywheel cab booking application. And I have a booking management which will facilitate my cab users or my customers to book a cab. So when a customer makes a booking, I want them to be served with an cab allocation and a driver allocation. So this is the big picture of the system that I am trying to build. So I have made use of the serverless services that we have been discussing about in this presentation to build my business application, and it looks like this. So I have an driver onboarding application. It has a mobile interface through which the driver would register their details, which gets compiled into a service bus message and gets into a service bus queue. I have a logic app which continuously listens to the service bus queue, picks up each of the information, validates the information with the help of an function app, because I needed here to perform certain validation, some computation. So for which I have used an Azure function, and the Azure function will return back with the status of approved registrations. Only the approved registrations will get into my database to have a complete database of my driver details. And the booking management would look like I have a mobile interface for my customers to proceed with the booking. For every new booking, I have a service bus message pushed into my queue, and I have a logic app listening to my queue. So this logic app is a queue triggered logic app. Whenever a message comes into my service bus queue, it is going to trigger my logic app, and I have a definition of workflow which defines what are the sequence of steps that has to be carried out for any new booking, and which also involves certain computation done with the help of Azure functions. And with the status updated by the Azure function, I am pushing that message into a service bus topic with multiple subscriptions, and I have got filters defined in my topic subscriptions, which will segregate my bookings based on the region or status and so on. And I have independent applications that will look for messages in each of my topic subscriptions to send and booking confirmation to the customer again. Here is a vehicle management application. This is kind of complex because I wanted a real-time telematic application which will tell me at any point in time what is the status of my vehicles that are across the country. So the telematic systems installed in my cabs are going to send stream data to my event hub, and my event hub is ingesting the telematic data My event hub is enabled with capture. So it captures the stream of data into my storage blob. At the same time, it also emits an event to my event grid, and the event grid will let my on-premise application, which is exposed to cloud using an relay. It will send an event to the relay saying the blob is ready for you to process now. So here we are dealing with two event handling services. One is an event hub, another is an event grid. So how are they different is like, so the event hub is dealing with events which are data intensive. Say each of the event that is being ingested by the event hub has got some useful information which has to be captured for further processing. Whereas this event grid acts like an event router. It just informs my relay that there is an event which is ready for you to process. So the moment it intimates the relay that the blob is ready to be processed, the on-premise system will pick up the blob and then process it. So why I have put an on-premise system to process the events here is like, say, still like we can find the industry trend being people are moving from on-premise solutions to cloud. So there could be a great part of legacy code which cannot be readily moved into the cloud, but still you want to enjoy the benefits of serverless services, say like easy scaling or pay as you go. So you can still retain and legacy code on your premise, and you have got Azure Serverless Services which can help you connect your on-premise applications to the cloud at ease. So that is what we would like to convey through this application architecture. So with the help of Azure Serverless Services, I have to admit like building and complex business architecture like this has become very simple. Say like we can just focus on the core business that we would like to solve, and we have got the scaling or the infrastructure requirements met with the help of Azure Serverless Services. So as I was building this application and trying out with the simulated inputs to check how does it work, I discovered certain challenges, and these are certain challenges we discussed with our customers or attendees at Ignite too. So these are certain challenges that most of the Azure users have expressed they like agreement on, like they do face similar challenges. So let us try to check what we have got in Serverless 360 to overcome these challenges. See, the challenges being like, I do not get to view the application on my Azure portal. Say, let me show you what do I get to see in the Azure portal after I have built my serverless applications. All that I get to see are bunch of resources, and I find them to be spread across various regions, various subscriptions, various resource groups, and it makes me hard to understand which is the business solution does this contribute to. So here is where an interface like what Serverless 360 provides can add value. So in Serverless 360, you can represent your application architecture with the help of the composite application hierarchical view. You can group the composite applications or the components of different composite apps into composite application groups, and you can have a better picture trying to understand what are the different components of this application and what is their status at any point in time. And interestingly, these services that I have mapped into a composite application can be from different Azure subscriptions or regions or tenants, and they can be mapped into a composite app to work together or to represent your business application. And let me look at this flywheel cab booking application. So at any point in time, I want to understand how are my resources or my services working together, isn't it? So I found Azure portal to be really good to build these applications, but it is not that very good when I have to monitor them or when I want to understand the real-time status of them. So application insights is indeed good when I am building my function app. So it gave me an real-time analytics of how is my function app performing at any point in time. But it is restricted only to an function app. So what do I have got for my service bus queue? How do I diagnose when there is an dead letter message in my service bus queue? Or how do I understand whether my logic app has encountered a failure or not? So these are certain questions which I soon started realizing when I had to support my serverless application. And that is where we have got capabilities in Serverless 360 that can make your life much better when dealing with Azure serverless applications. So this is an completely customizable dashboard wherein we can create widgets that would represent the key parameters that I am concerned about. So I can create a widget to show me or pop up on the number of dead letter messages and specific topic subscription or a queue has got, or I can understand the run failures of my logic app right from here. I can monitor on the key performance indicators of my Azure function app or an event grid subscription and so on. And it gives me a clear application visibility with the help of a service map. So here I get to understand that how does each of my resources interact with each other, and is there an error? I can understand what is error they are encountering, and this would invite me for an action to restore the business. And I can also have multiple service maps which give me a close view of each component of my business application. Say here is my driver onboard system alone, and here is my vehicle management system alone. So it gives me a picture which similar to what I had in my architecture diagram. So this would be an great tool to enable your support team, whoever is going to provide support on this business application, to understand how does each of the entities interact with each other. And they can be proactive when they find an issue with one of the resource. Instead of waiting for the customer to come and let you know that there is a problem, the support team can be proactive to inform their respective DevOps engineers to react to it. And as I was working with these resources, I had a few challenges in managing them too. Say, I was talking about processing the dead lettered messages in my service bus topic or queue, which is straight away not a solution available in Azure portal. So I am looking for an option to help me restore the dead letter messages in my service bus topic or queue. So here we have got an out-of-box message processing capability that will help you pick up the messages from your dead letter end of a service bus topic subscription and process them. When I say process, you can do actions like viewing the message details, or you can choose to repair and resubmit a message. When I say repair and resubmit, you can modify the content of the message or add in custom property, or you can proceed with the resubmission with backup enabled. And we were discussing about some of the key properties of service bus queues when we were talking about Azure Service Bus. So you can find Serverless 360 to pay attention to all those key capabilities. So you can modify the time to live of an message, which will decide when this message should get dead lettered. You can set and schedule the queue time through which you can decide when the client application is expected to pick up this message and then process. You can set a session ID ensuring the message first in first out delivery is ensured. You can set a partition key ensuring the message is being taken care of by a specific message broker, and you can proceed to resubmit to one or more of the entities along with backup to a blob. You can choose to resubmit either to the same or to another entity. And we have also got capabilities that will ensure message loss when you are resubmitting to an duplicate detection enabled entity. So as we were talking about service bus queues and topics, I was mentioning about requires duplicate reduction property. So here is an option to resubmit a message to and requires duplicate detection enabled property without message loss. That is, you can regenerate the message IDs, ensuring the message IDs are unique and hence the message will not be lost when you try to resubmit it to a duplicate detection enabled property entity. So these are indeed helpful, but how feasible it is to do the similar activities for a number of service bus entities. And that is where our intelligent automated activities will come into picture, wherein you can create an activity that will help you deal with your dead letter or active messages without any manual intervention. You can schedule a dead letter activity to purge unwanted messages by their dead letter reason, which can even be a custom dead letter reason. This activity can be scheduled to automatically perform this purging of invalid messages without any manual intervention. You can even process your active messages which are left behind unprocessed by your client applications. So I can pick up my active messages from a specific topic subscription and resubmit them and delete so that the failover system can take care of for processing these messages, thus ensuring none of your customer orders goes unprocessed. So when I was working with my Logic app is connecting to an Azure SQL database. So all of a sudden I observed that my Azure SQL database region in which I have created the database has gone down, which has got a number of Logic app runs to fail. So I wanted to restore this transactions. So the one solution that I can do is resubmitting the Logic app runs. But there were thousands and thousands of runs which has failed. I wanted an intelligent automation which will help me pick up only those run actions which are connecting to the database that has failed. So I make use of the automated activity in Serverless 360, which will check whether a specific run action has failed with and reason could not connect to database. So I can create an activity like this, which will scan my Logic app trigger and run histories to look for that specific run action with an expected state of failure with the reason could not connect to database and resubmit that. So when I had a storage blob which was capturing the event hub streamed like processed event hub data events, I want this blob to be cleaned after a specific duration of time because I'm going to pay for whatever I have accumulated in my storage blob. So I wanted an automated system that will look for my storage blob and clean it without any manual intervention when the duration of the data is more than 7 days. So I do not want to retain any unwanted blob information for beyond 7 days. So this automated activity could come for rescue. And I also wanted to deal with the dead letter messages in my event grid subscriptions. So the challenge is similar, like when I when I have a number of messages in my event grid subscriptions which are dead lettered, I want to auto manage them. That is, I want to clear them from my event grid subscriptions. So here is an option which will help me view the dead letter event. So this sort of view is not possible through the Azure portal at all. So here in Serverless 360, I can view the details of the dead lettered event in event grid subscription. I can also perform actions like repair and resubmit. Say if I want to modify the event details, I can do that and then proceed to resubmit. It could be the properties of the event or it could be the content of the event. I can proceed to resubmit. Or if I want to just resubmit, a bulk resubmit is also possible. Or if your requirement is as simple as I just want to remove them, I can choose to purge them off right here. So this level of processing capability I could not find in the Azure portal to deal with my event grid subscription debt letters. And when I wanted to monitor my application, my expectation was to monitor my serverless application, not to monitor an individual entity in my serverless application. So I was looking for a consolidated monitoring solution. But what I could find in the Azure portal is all tied up to a single entity. I had Azure Monitor, Application Insights, Log Analytics, but all of them were dealing with a single entity. But I wanted an consolidated report like this, which says what is the status of each of my entity that participate in this business application at this point in time. And in case of an error, what is the property of that entity which caused me an error? And the monitoring that I could find in the Azure portal is based on a metric, which is an historic information. But I wanted a near real-time monitoring, which will tell me about the status and properties of the entities that I am dealing with. So for me, I have got a range of monitors in Serverless 360, which can help me in performing consolidated monitoring at various perspectives. Say the status and threshold monitors can help me monitor on the status and the properties of the entities. But how they are different is a status monitor will give me an scheduled alert at time uh, defined times of a day of a week, and a threshold monitor is going to give me an alert as and when a violation is detected. So if the dead letter message count of my topic subscription goes above 0, I want an alert. Then the threshold monitor will give me an alert whenever as and when the dead letter message count has breached the expected value. Whereas the status monitor is going to give me an alert only in the next scheduled hour when I have scheduled to generate and report. And if my requirement is to check on the performance or consumption of my application, then I have a data monitor which works on the metrics of my Azure resources. So I have got an extensive set of metrics that will give me the performance of my resources in various perspectives. Say I can look for metrics like action latency and run latency, which will help me understand how are my logic app performance is, or if I am concerned about consumption of my logic app, I can check on metrics like total billable executions. Or if I want to detect whether my service bus entity is available for processing or not, I can choose metrics like server errors or user errors. So when there is a server error, which could be caused by scenarios like when the region has gone down, and so such scenarios can be detected with the help of server errors, and with the help of user errors, we can understand how well is our client application communicating with the Azure in service bus queue or a topic. So if my client application is generating exceptions, then that would reflect in the user error metric of my service bus queue. So by wisely choosing the metrics on my resources, I can detect any anomalies in the performance or if there are unauthorized access on my Azure function apps that can be detected in the calendar view, wherein an error would be reflected, and we can try to understand what was the reason behind the failure. And when you have workflow definitions or critical business defined using logic apps and function apps, it is critical to understand their failure. And here you have got a watch monitor which can help you detect failure in your logic app or a function app. You can also whitelist a specific set of errors that we are concerned about, because many a times a run failure is quite common, which could be restored with the help of retry policies configured in a logic app. So we can be very specific about what is the error that has to be brought to my notice with the help of a watch monitor by specifying the reason. And all these monitors can be integrated with a rich set of notification channels through which you can keep your stakeholders informed on. So Serverless 360 supports 7 different notification channels which can be configured at the uh, uh, settings section, like Slack, PagerDuty, Teams, OMS, Webhook, SMTP, and ServiceNow can be integrated, through which you want to keep your stakeholders informed on the status of your business application, which made my life much easier as I could integrate using Teams and keep my team members informed on how does my application look like, and in case of any error, it can just pop up on their Teams message channel. And I also use the user management to define the appropriate user access policy for my team members. So the development team was provided with a level of permission on different set of applications. Say the booking management team was provided with necessary permissions, which was quite simple and straightforward to define on what are all the operations they are allowed to perform on my resources. And all the actions that the any user perform on my resources through Serverless 360 is all governed and audited in the governance and audit. So this way, Serverless 360 can fulfill or overcome all the challenges that I could encounter as I was trying to support my serverless application in the Azure portal. So this indeed is a complementary tool that can help you better operate with your serverless applications through the Azure portal. So we do have a community initiative, Serverless Notes, wherein you can find tips on working with Azure Serverless Services, and you can find the experts in this area talking about these serverless services. So please do join our community initiative and acquire knowledge from the leaders in the space.
Covey.co